All right, so for problem number one,
Mhm.
wait, let me just actually pull up the, where is it? This one? Yeah, okay. So for problem number one, it says the work required to expand the gas is calculated by this formula, which is the definite integral of this data right here. It
Mhm.
says as the piston is lifted, the pressure in the sealed chamber will fall. The pressure and the volume after equilibrium are listed in the accompanying table. Number one says plot the data in MathCAD and in a scatter graph. And it says show only data points. So you can't, like in the practice exam, I don't think you could copy this because I think it was a picture. So you'd have to actually write it out yourself. But
Oh,
it's
you
not
can't
that.
copy, like select it and then copy it like she would.
Not on the practice exam here because it was like it was a picture. It wasn't.
Oh, I see.
Yeah, so you'd
Okay.
have to just go on
Type it all
Excel
in.
and then just put it all in here, which is a 1.3. I'm actually not even gonna write the entire thing, but you get the point. You'd have to
Right.
put it right here, and then you would copy it, and then you would insert a data table. You go to
Tools.
yeah.
No, I
Well, no,
think it's
insert
and then
data
data and then table.
table. Yeah, and then you
And
put
then
data here.
data. And then on the first one,
Can't move it.
I'm gonna start what's it called? 1.7, 2.1, 2.5, 2.9, 3.3, 3.7, 4.5. This one is 4.50. And 1.19. Okay. Yeah, so it'd be copy and then into MathCAD. Okay, so after you copy the table, right? Insert data table, paste table.
Yeah. So you go here, and then you press paste table there.
Yep.
And then you have your whole data. You could shrink it. You don't need the entire thing showing. So what we're gonna do here is we're gonna extract the x values and the y values. So for variable x here, or capital X, it's going to be set equal to data. Let me just write it out here. X equal to data, and then in the matrix toolbar, it says matrix column here. And pretty much what you're gonna do. So if you have your start, that's your arrays starting at 1. So how you do that is go to tools.
Oh,
so
worksheet options. Why is it that we started at 1?
I mean, just because you don't have to. Yeah.
Okay. Yeah. How is it that we do that? I think it was tools.
Yeah. So
worksheet options.
tools, worksheet options, and then array origin, or 1.
Oh, why didn't I do it? Tools, worksheet options, 1.
I mean, it just makes more sense for it to start at 1 and not 0. So
okay, yeah. And then how did we get the little number on the top? I forgot.
This is the matrix toolbar here. Let me see if I can.
Okay.
This thingy. This one. This is matrix
okay,
column.
gotcha.
Yeah.
Yeah. And then that would be 1.
1. And then for y, you would do data,
the same
but
thing.
2.
Okay, perfect.
Yeah.
Yep.
So
that one's pretty easy.
So these are the values for this right here. So when we need the x values, we just put x here. So we're gonna do pretty much the same thing that we did in Excel. We're gonna give MathCAD the coefficients here. X to the 3x, x cubed, x cubed, x squared, x, and 1.
Okay.
Now, if we were to want it to start at 0, then we would take this 1 out. But since we don't want it to start at the origin, we'll just put the 1 there because we want a coefficient. We want a constant at the end.
Okay, gotcha. So it'd be f of x, and then the matrix would
Yeah,
be,
so you create a matrix.
1, 2,
Go
3.
here.
So it'd be 4, 1. Then okay, and then x to the third, x to the second. Okay. X and 1. Okay. So we got that.
Yeah, so now you could just pick a variable. Here I'm going to pick C for coefficients.
Okay.
So we're going to use this function here. It's called linfit. Not to be confused with lnfit, which he tells us to use in, I think, in the homework 4.
And linfit is what really?
It's just pretty much the same thing as the regression analysis package thingy in Excel.
Okay. So it just evaluates your.
Yeah. So we give it the x values, we give it the y values. So capital X, capital Y, and then we give it the coefficients, which is f, function f here.
Oh, okay. I was gonna say, why doesn't it say C then? Okay. So, and then equals, and
then it gives you the coefficient.
It's red. Hold on. Maybe it's too high. Yeah, there we go. Okay. Yep. Wait, why did I get different than what you did? 0.41. Yeah, I'm getting a different number. I don't know why.
No, sure. Is your data the same?
Let me see.
Wait, hold up. Can I?
Yeah, there you go. Oh,
it's behind of it.
2.34. Maybe that's why. Yep. Let me see the, yeah, so it's 3.44, not 2.44 for the second. Yeah, that one. That's why it's off, maybe.
What the heck? Okay. It undoes everything else, but it doesn't undo the table here. There. Okay.
I think it's still in there.
What's still in there?
So on your second row, second column,
oh,
it should be 3.44.
That's right. Wait, hold up. Then how did I get the same answers as her? I'm confused.
And then your after that one, it should be 2.79.
Hold up. What?
I think you have that wrong.
Yo, where am I getting these numbers from? Hold up. Wait.
Yeah, your numbers are off.
By a lot.
Yeah. Maybe it's a different problem.
I don't think so. Hold up.
No, that's fine. I'm gonna
write down 113, 143, 158, 177, 202. Oh, they're not wrong. They're I just had it scrolled down. I had it scrolled down.
Oh.
Yeah. So I was showing. Oh wait, hold on. Let's see if I can. I can't even redo it. Oh my god. These tables are so annoying. So I had it scroll down like this. You see how the row was?
Oh.
Yeah.
Oh, I see. Okay.
Yeah, it was dumb.
Well, okay. Let me check mine's against yours then, because seemed a little off still.
Sorry, let's scroll up there.
Yeah, that's so weird. I'm still getting a different for my C. So for the coefficients, I'm getting 0.148, 0. Yeah, that doesn't make sense to me. That the equation that you have on the very top after problem 1.
This one doesn't affect
that doesn't
anything.
matter, right?
No.
Right. That's so weird. Okay. Yeah, I have everything the same as you do. So
Did you do the caret thingy? Caret?
yeah.
And...
Yeah.
Hmm.
Oh, I know why. Sorry. I figured it out. I have X to the, okay, now we're good. Sorry, that was my bad.
Okay, so we're good.
Okay, yes.
So now we have
Tap to coefficient.
So now we have the variables here and the coefficients. So to get the formula, you do the dot product or you just multiply them. So I just named mine TX for trend line, equal to the coefficients times the variables here. So this gives us our trend line. So if we were to plot it here, so first we would obviously for number 1 here, plot the data. Now we have our X and our Y's. We plot X, X and Y here, right?
Okay, so now we have a scatter plot, and then on the y-axis, it's going to be Y.
Yeah, hold on. Let me just do it again. Here. So you create a graph scatter plot here. Capital Y, capital X, and it gives us by default, it gives us a line. So here we could cross it. That doesn't really matter, but here, turn this trace, the line's red. So the very first line that you draw is going to be red, and you set it to point, and you set the weight to 2 or 3 or whatever you want it, and it gives us dots here.
Okay, perfect.
So that's number 1. It says plot the data, show only data points. That's what we did. Change the line to points. Number 2 is fit a third-degree polynomial to the data using mathcat function linfit. Show the trend line in the graph and determine the R-squared value. So we started doing that already. We found the equation TX here, and we can actually just plot it here. Wait, hold on. All right, then. Okay, so for X, you just put lowercase x,
comma,
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 t,
lowercase x.
Yeah.
And then for the other one, it brings it down to the comma, right? Comma.
Yes.
And then T of X, which is your trend line.
And then it gives us a trend line here, right? So what you have to do is change the range here. You can set this start at, I think it's 1, I think I had it at. And then this to end at 5. Hold on.
5?
Yeah. So I had it 1 to 5. Yeah.
Okay. Gotcha.
Yep. And then, so now we have our trend line on our graph. Show the trend line on the graph and then determine R-squared. So for mathcat to determine the R-squared value, we use this core function, CORR, to determine the R. So what you need is you need the actual Y values and then the predicted Y values, which come from your trend line.
Okay.
So,
and that's core.
Yeah. So for your predicted Y values, this is called vectorize, where it pretty much gives you a vector instead of so if you were to actually do this, I think it would just give you a singular scalar number. But if you wanted to give you a vector, what you do is use this vectorize function. Let me just rewrite it here. So it's in here in the matrix toolbar, you vectorize, and then t, and then we want to use the same x values here. So we use the capital X.
Okay.
Yeah. So now what we have is YP is equal to the Y values from the trend line at the same X points as the data table here.
Okay.
So we have X and Y, and then we use these same X points for this trend line. And we have Y predicted here, YP.
Okay. So,
and then we use those two and give that
R. to core is in one of these, or
no, you just write it out.
Okay. Y, comma, Y. Wait, Y, comma, Y dot P, right?
Yes.
Okay.
Okay, so for anyone that doesn't know, you use dot P because you're just naming a variable here. You're not referring to a value in the Y vector here. You're just naming a variable.
Right.
Just in case. So MathCAD just gives you R.
The way she explained it yesterday was like, let's say, for example, you're referring to in the coefficient matrix 1.281, then you would use bracket in the Y bracket, right?
Yeah.
Bracket 1, comma 2 or something like that.
Yeah.
Yeah. Okay.
So MathCAD only gives you R with this core. So what it does is it compares these two values and then compares how correlated they are and gives you R.
Okay.
And then you just square that and then you get your R squared.
Got it.
Yeah.
That's equals. Okay. Nice.
So that's number 2, part 2 here. Part 3 says calculate the work required to expand the gas from a volume of 1.3 to 4.9. So you can go about this 2 ways. One way is just to define V1 and V2 as 1.3 and 4.9, and then let's rewrite this. So W, you said W work equal to, you go to calculus toolbar.
What is it asking for again? Calculate the work.
To calculate the work. Yeah, so using this formula here.
Okay.
They give you the formula. So work is equal to the definite integral of the data table.
Okay, so we have to define V1 first.
Yeah. V1 and then define V2.
1.3. Where did you get V2 from?
Between 1.3 and 4.9.
Oh, okay, it says it, sorry.
Yeah.
Gotcha, okay.
So you put V.1 and then V.2.
Right.
And then here you can't use the data points because you need a function here. So we are going to use our trend line that we found.
Okay.
So T of X and then dx because that's the independent variable here. And then you just equal and you get this number.
Okay.
I mean, you also could, like, if you don't want to define these here, you could just go just type them straight in here, 1.3.
Okay.
4.9, and
but you might as well because you're taking the time to call it out anyway. So
yeah.
Okay,
or I mean, then, if you didn't want to, you could just do that. But
right. And then the last one is dx.
Yeah.
Equals 7. What did you get for that one? 7.794. Okay, perfect. Yep.
All right, and then that's number 3 or part 3. Part 4 says the work calculation could also be solved using numerical integration between 1.3 and 4.9. So numerical integration is integration through like calculations, like I guess it would be like geometry, like right Riemann sum, left Riemann sum, and then trapezoidal sum. So those are numerical integrations. This right here is what's the word? Definitive. Wait, this one. Yeah, this definite integration.
Okay.
Because you have a function, and then it gives you the area under that function.
Right.
Here you're using geometry. You're drawing shapes on the graph to
the
predict
trapezoids
it.
to
In
get
this case, it's
the
a trapezoid.
area.
Yeah, in this case, it's a trapezoid. This one.
Okay. So that's so we need to write that formula first.
Yeah. You don't have to, but might as well. So this is the area of a trapezoid here. So let's say we wanted the area between 3 and 4. You would subtract 4 minus 3 to get the space between here, which would be 1. And then y1 plus y2 divided by 2 is you just take the average of the two bases. So the value at 3, the y value at 3, and the y value at 4, you divide by 2. You pretty much get a square. And then multiply it by the base, and then you should have the area.
Okay.
So I think what she did something else. I think she did like a solve block thing. Oh, what the heck? Oh my God. All right, give me a second.
It's okay.
What's up, Rudy? Hello?
He had to he had trouble. He's logging in right now, so he stepped out really quick.
Okay. Gotcha. How far along is he?
We're still on question 1. I think on the last part of question 1.
Nice.
All right. So
someone else came on.
Oh, that's nice.
Hello.
Hello. How are you doing?
Good. How are you?
Doing great. Let's see, practice quiz. This one.
Yeah.
So what she did was this thingy. She said the vector here, this would become a vector here. So A, this would be a bracket I. Set that equal to the formula here. So for all
that would
the
be
ones,
bracket, or
these would be brackets. Yeah.
Period.
All of these would be brackets.
Okay. Oh, she said a range for I.
Yeah, she said. Oh, wait, would it be bracket?
No, it would be period. No, because you're not really referring to a specific.
Oh yeah, wait, hold on.
Placement. But your way looks easier.
Wait. Now I really want to know, does she use period?
I'm pretty
P1.
sure.
What is P1 though? No, she is referring to, because she put this is a vector. P is a vector of all the y values. So instead of x, y, she did v, p.
Okay, let me see, scroll down.
So p is a vector. So here you would be p bracket I. So when I equals 1, it's calling the first value of the p, or this value here, 4.5.
Oh, okay.
Yeah. So these are all brackets.
Okay.
And then, hold up. So, I mean, she kind of did it the same way, except I used the for loop. I mean, it's good practice, I guess.
Yeah.
So I think her way is like simpler, but this is how I did it. I didn't even know she had released the solutions after I did this. So,
okay.
So
well, I have your way written down
mine
anyways.
is kind of complicated.
It is. So should we just go through her route then?
I mean, if you want, I'll explain the way I did it.
Okay, go ahead.
But it's fine. So, so let's say for I equals 1. I think there's 10 rows in this column, in this thing, right? There's 10.
Yeah, I think there's 9 or no, there's 10. Yeah.
There's 10 rows. Yeah. So there's 10 rows. So she didn't do 1 to 10 because here it says I plus 1. So if you were to do 10 plus 1, it would be 11. It would be trying to find an 11th value in
and
one
we
of
don't
these,
have it.
but there's not one there. So we just use 9, just one behind.
Okay, can you really quick, I think I remember where it's placed, but I know it'd be helpful to show also like that range, where that range tool is on the matrix toolbar. You know what I mean?
This one, this thing, range variable.
Yeah.
So I, and set that equal to.
So it'd be I equal to 1 and then range 9.
Or you could just do 1 and then the semicolon. So semicolon 9.
Oh, okay.
Yeah.
I didn't know that.
So either way you could do that. So what it's doing here, it's taking P1, which would be this first value, X. Wait, no, this one, sorry, the Y value, 4.5 plus this next value. So 1 plus 1 is 2. So it'd be taking 4.5 and then 3.4 and then adding them, then dividing by 2. And then now you multiply.
Really quick before you continue, how do you know that PI is the Y value?
Here, so she didn't set X, Y. She did V for X, V for the volume here, and P for the pressure.
Okay, got it.
Yeah. So you divide the, what are the bases? I don't know. The two heights, I don't know. So you add them and then divide it by 2. Then you multiply it by the difference between the x's. So V I plus 1 would be V2. So it'd be 1.7 minus V1, which would be 1.3.
1.3. Yep. Okay.
Yeah. So
okay, yeah.
It gives that value.
Easier then.
Yeah, this way is easier.
Okay.
And then it gives that value to A1, which would be this first value here. So this value here is 1.588 is the area between 1 and 2.
Right.
And then this next value is between 2 and 3, and then 3 and 4, and 4 and 5. All the way up to, this is 9 and 10. So it's between 9 and 10.
And those values, again, just to the values that we have here, they're all done with bracket, right?
Yes, all of these are done with bracket.
Got it.
So when I equals 1, A1, or this first value here, is equal to whatever you get here. And then it goes on I2. So for A2, the next value is equal to whatever you get here.
Nice.
So the way I did it, this is definitely easier, but the way I did it, right? So I set this work variable W. This is a for loop, right? So this first part here does the same thing as this. So I goes from 1 to here. I made it a little more automatic than what she did here. So let's say they alter the number of rows here. You still have rows of data minus 1. So here, instead of using 10, she used 9. So she subtracted 1 from the end. That's what I did here. So since there's 10 rows here, minus 1 is 9, right?
Okay.
For this case. Now, if they like added more, if they, quotation marks, I don't know, added more rows here, it would change this.
Okay.
Yeah. So, and then this is just this, what you did here, but instead of this little symbol, I use the arrow, which is what you use inside the program here. So A1, pretty much the same thing as this. It's the exact same thing as that, actually. And I don't know what this A is for. I don't know if I honestly don't know what it's for, but it's there, and I think it has to be there.
Okay.
But that's for a for loop, and then it gives me the same value. So what this is, sorry, this is right here. So it gives us the W vector is same as this A vector here, right?
Mm-hmm.
So I didn't show it, but it's there. This right here is, hold up, here, in the matrix vector sum,
Mm-hmm.
W. So it adds up all the values of vector W, and then you just, hold up, and you just get that,
Okay.
which is what you did here.
So it's just adding all of those,
Yeah.
the matrix, what's in the matrix. Wait, so for some reason I'm getting a red. Can you scroll up to her work really quick? Yeah, for some reason I'm getting a red P on the first PI.
Oh, because we named them X.
Oh.
Or I named
So I have
them
to
X.
change, I have to change them to X, big
Yeah.
X, right?
Unless you just want to change the other X's to P's,
Oh,
if that makes more sense to you.
Yeah. Okay.
So everywhere where you see capital X, you change it to V, and then capital Y, you change it to P.
Right. Change that to P. Oh no, I'm gonna confuse myself. Shit. I think that's right. No. Yeah, never mind. Let me
I have a
just
question.
change that to X.
Yeah, what's your question?
How do we change the starting value in the data table to 1 instead of 0?
Tools, worksheet options, and then here, array origin, set it to 1.
Thank you.
Okay, I'm good now. I just changed the last ones to X because that's just gonna be easier. And the other ones to Y. So whatever I have, she has as P, I have of X, and then, right?
P is Y, and then V is X.
Oh, so I have to change these then. Okay. Okay, and then I should be able to do A equals, and then, yep, I have the same thing. Cool. Oh, and then area. What is that last part?
It's that sum thing I showed here, this one.
Okay, so I
Vector
just
sum.
have to vector sum of A and then equals.
It should work.
Okay. Yeah, it worked. Do I have to write area?
I don't think so, but it might help. I don't know.
Okay. I'll just write it anyway. Okay, cool.
All right, then. So you good with problem 1?
Yeah, it wasn't too bad. I don't
Yeah.
think. I just got to go over it again, but.
So just pull this out of the way here. So for problem 2, it says mass M is suspended by 3 cables attached to 3 supports, and then yada yada. And then it gives us the 3 equations. So we have T1, T2, and T3 as our unknown variables. And then these are coefficients: 1 over root 35, -3 over root 34, 1 over root 42. And then here we don't have a T2, so we put a 0 here, and then just do all the other ones.
Okay.
So MG here is just a constant.
Did you type those in or you just copied them in?
I typed those in. There's no copying.
Okay, got it. And with period, right? Obviously.
Yeah, these are all period. T period 3, T.3.
Okay, sorry, go ahead.
So now we have our coefficient matrix, which was, let me actually, forgot where I had that. where do I have the thing? This one. All right, so number 2, part 1, it says find the coefficient matrix, which is this right here.
Mm-hmm.
Then it says find the determinant of the matrix. So you go on a matrix toolbar, this matrix toolbar, and you hit determinant.
Determinant.
C equals, and then you get that.
Okay, that's easy.
Yep. Part 3, find the values of the tensions, T1, T2, T3 for a weight. Mg equals 500 newtons. Use the inverse of the coefficient matrix to find the solution of the system of linear equations. So Mg equal to 500. So when you take the determinant, apparently the matrix can't have any units on it. So over here somewhere, if you have units, you can't take the determinant of C2. So
okay.
just
unitless.
keep that in mind. Yeah.
Okay.
So you could add the units later, but you know.
Where'd you get the Mg from?
Mg is,
they gave it to us. Okay.
Yeah, equal 500.
And RHS.
Yeah, the right hand side. So all your you would do 0, 0, and then move Mg over to the side.
Okay.
Mg. Yeah.
Got it.
So you multiply both sides by the inverse of the coefficient matrix, right?
Mm-hmm.
And you should get T. So what you do here is rewrite it if I can.
Okay.
Hold on. So C, and then in the matrix toolbar, inverse, right? Space twice. Dot, product, multiply, right hand side vector here, and you should get the answer here.
Okay. Wait, hold on one second. Mg equals 500. Right hand side. Okay, matrix inverse. So that's T C to the, oh wait. I could just do it with the arrow, right?
What with the
Or
arrow?
the C after T.
I think
Right there.
so. Hold up, wait. Let me just.
Or do I need to do it
Mm,
per command?
hold up. Let me just rewrite this whole thing actually. Just messing up. Yeah, you could.
Okay.
Either way is fine.
Let's times the right hand side equals. Okay.
So this is T1, T2, and T3.
Got it.
So now it says find the value of the tension T2 using Kramer's rule. So what you do is you make a new matrix here. So in this case, we'll call it C2 for T2, and then set that equal to the coefficient matrix. So now C2 is this right here. But now we're going to use that column thingy that we used. So C2, and then use this matrix column.
C2,
so what we're saying is we're going to turn column 2 of C2 and replace it with this vector here.
Okay, say that again. You're going to replace, so column 2 in that matrix, right?
Yeah. Set it equal to
this. Set it equal. Okay.
Yeah, so this equal thingy here.
My God.
So now if we call C2 here, if I could type LC. You see? So it changes these two decimals, but it's these values here. And then it changed the middle to the right-hand side, you see?
Okay.
So now to find T2, you find the determinant of the new matrix that you made here divided by the determinant of the original matrix, coefficient matrix.
Okay, so the determinant of the
C dot
C2.
2. Yeah. Divided by the determinant of C. And you should get this same value here for T2.
Divided by the determinant of C. Okay. Equals. Okay. That one's a little confusing, but I'll just go over it again.
Yeah, just finding the coefficient matrix is pretty easy. Just look at this, and then just go over. I could actually just write it out right now. We're just going. So what we did was, so C equals. So I'll just the right hand side. We'll just say it's R times T, right?
Okay.
So this is what our coefficient matrix is.
Right.
Hold up.
The one at
Wait. That's so wrong. Hold up. So these are our coefficients, right?
Which is that matrix there.
This matrix right here.
Yep.
These are our variables, which are T1, T2, and T3. This one right here. So this is a 3x3. This is a 3x1, right? If I'm not mistaken.
The right-hand side, right?
Yeah. No, these are.
Sorry, what's T again?
These are our variables. Sorry.
Yeah.
So imagine a 3x3. Imagine this one right here.
That's
right
the
here.
3x3.
See, times this is a 3x2, right? T1, T2, T3.
3x1.
Yes.
Okay.
And then you equal that to the right hand side, which
Got
is
it.
so you cancel these out, so you get a 3x1.
Right.
Which in this case would be this one right here. 0,
yeah.
0, 500.
Mhm.
So what we do, you can't divide by matrix. So what you would usually do is divide by matrix C, but you can't because you can't divide matrices. So what you do is you multiply by the inverse of this matrix.
Okay. On both sides.
On both sides, yeah. So what this gives you right here, this is equal to 1. It gives us the identity matrix that she talked about. I think it goes like this or something.
Yeah.
Yeah, so it gives us this. So any matrices, wait, hold up. Any matrix or vector you multiply by this, it returns the same matrix or vector.
Okay.
So it's pretty much equal to 1. So this times T1, T2, T3 is equal to T1, T2, T3.
Got it.
So we're just left with this T1,
T1,
T2,
T2,
T3 equals to the right hand side.
0, 0,
So right hand side times the inverse. So if we multiply the right hand side times the inverse, we should get the values of T1, T2, and T3.
Right.
So that's what we did here.
Okay.
Yeah.
Got it.
And then Kramer's rule, that was also from Excel. Sorry. So if you want to go over that lesson or those PowerPoints, that probably be best. And that's problem 2. Let me put this away. And then problem 3. says orifice meters are commonly used to measure flow rates. The equation is this right here, where A1 is the cross-sectional area of the pipeline and A2 is equal to 0.7 times A, being A, the area of the orifice, as can be seen in the figure. It gives us all these values here, and this value right here, this value right here, and then asks us to find A. So we have this equation right here. You don't have to write this down. I could just delete this and it would be fine.
Okay,
But
good.
I just wrote
I
it.
was typing it now.
I just wrote it down anyways.
Okay.
So these are all the values they give you. A.1 is equal to 7.92 centimeters squared. C.D is equal to 0.65. There's no units there. H.1 is equal to 20.4 centimeters. H.2, 17.4 centimeters. And G is equal to 981 centimeters per second squared, or 9.81 meters per second squared.
Got it.
Yep. So for calculations here, you set Q, Q of A2, A.2 here. So this would be similar to using Q of X, where X is your independent variable. So if you were to not include this here, let's say, just put Q here, it would ask you to define A, because you're not telling it that there's an independent variable. So it's asking for A.2 to finish this calculation. But by including this right here, A.2, you're telling MathCAD that this is an independent variable. You don't need to define A.
Okay. Can you say that again? Sorry.
So this would be similar to writing Q of X, where
Okay.
X is your independent variable.
Okay.
Right. So this is just telling MathCAD that this is a function based on A2. Okay. And it's not going to ask you to define A2 because this is just a function, right?
Right. You're defining a function there.
Pretty much.
Okay.
So if you were, like I said, if you were to delete this thingy here, it would ask you to define A2 because it's looking for A2, but it's not finding it. And if you were to define A2 equals 0.7A, it would then ask you to define A. And then, but you don't know that.
Right.
So here, what you're going to do is use the solve block here.
Okay.
You would start with the guess, right? A.2 is equal to 1 centimeter squared. Right. And then you write a given here, and you have to make sure that you don't press space, because if you press space, this turns to text and then it doesn't work. So
where did you get the A.2 from?
So it's asking us for A, right? And A.2 is equal to 0.7A, and in the equation it's A.2 here.
Okay.
So if you find A.2, you could just divide it by 0.7 and you should get A.
Okay, got it.
Or you could do it how she did it, which is similar, but you take 0.7 times. So everywhere where you, instead of writing A.2, you write 0.7A, right?
Oh, okay.
Here.
And then
0.7A, right? Hold up. This value has units, current. Hold on. There's, all right. So, so instead of the Q of A.2, it's Q of A, and in here you just do A given that, and then find A, this. So it would just give you A straight away. Or you could do it a step longer, how I did it. And then get this all back. Oh, there, okay. All right, or you could do it a step longer and then solve for find A2 first. So you would guess, this is a guess for A.2 given, make sure there's no space here. Q of A.2, and then this has to be a bold equal sign. So this is an equation that you're setting. They give you this value here, 172 centimeters cubed over S. So we want to know where the value of A.2, where this equation is equal to 172, right? And then it gives us A.2, and then you divide A.2 by 0.07, and you should get A.
Gotcha. Okay.
Yeah.
Rudy.
Yeah, what's up?
But on her solutions, she gets a different number. I think like 3.33.
Yeah. I noticed that she put. Hold up. I think I even wrote it in the chat somewhere.
Oh, okay.
Yeah. Wait. Hold up. Wrong chat. So if I could find it. Here. So you see how in the worksheet it says 17.4?
Oh.
Here she put 14.4.
Oh yeah.
Yeah. So
it's supposed to be 17.
yeah.
Okay. Okay. Thank you.
Yep. So I don't know if you were here when I mentioned it, but you could just solve for A directly.
Yeah, I saw you doing that.
Yeah.
Like switching up in and out. Is her solution manual like you could basically just mathcad her solution manual, and that's like there's no hidden trick in there, right? As long as you know how to do everything.
Yeah, just make sure where to put brackets and dots.
Oh, okay. Thank you.
Yeah. And of course, replace that 14.4 with the 17.4. And then you should be good.
Got it. Thanks.
And I think that's it.
Okay.
I
It's
don't know
not
if you
too
guys-
bad. I think it's just like going over it again and making sure to write it out right.
So I did homework 4 and it's kind of annoying.
Is it?
And it's not responding. That's nice. Oh, there it is. Okay. So here it's asking for numerical integration and then definite integration.
Wait, what's the first part asking for?
So gives us this. Oh, wait, I think I have it here. Homework for this one. Where's it gonna open? So it gives us this wall, this concrete wall, where it's asking us to find pretty much the area of this wall here, given all these measurements. So what you do is you take, so we would start at x equals 0 here, right? And this would be x equals 1, x equals 2, x equals 3, x equals 4.63 and 6.88. So those are your x's. For y, you would just add the length of this. So the usual way to do it would be to do 2 integrals, one integral for this top part, right? And then another one for this bottom part. Or you could just add the length, the entire length at that x value, and then put it here.
Could you expand the table? I'm sorry.
Yeah, I'm just gonna move it actually. I'll move it over because it's behind everything else. Where is my table? There.
Okay, so you're just adding basically the x values together and then the y values?
So our x values are these horizontal measurements here. You see them? So this would be 0, starts at 0. This first line right here would be x equals 1, x equals 2, this one here, x equals 3, x equals 4.63, and then it stops at 6.88.
Okay.
Right. So an integral just takes the area under the curve here. So if you were to add the area, this area right here, this one right here, with this one right here, you would get the area between these two, right? So the usual way would be to just do 2 integrals. So have 2 data tables, but you could just add the lengths here at that x value. So at x equals 0 here, you would add 3 plus 0.5, and you would get 3.5 here. X equals 1, you would add 2.84 here, up above from the x-axis, let's call it this dotted line here, plus 0.7. You would get 3.54, and then at 3, 2.35 plus 1.13, and then so on.
Okay.
So you're taking the area of the biggest, like the big section, instead of the area from the 2 broken up sections within it.
Yeah, pretty much.
Like you're adding them together instead of
Yeah.
taking 2 integrals.
Yeah. So
that's the table.
Yeah.
Okay.
Okay. Move this back. Well, like, why doesn't undo shorten the table? Why? And it's so finicky. I don't know why. But I could just do undo. Okay, so there. Why? Okay. So that's the data table. X for your X values, Y for your Y values. And then, so this is a wall that they made. So these are the frame of the wall. And the distance here is 9 inches. Yes. So it's 9 inches. So it's asking you how much concrete you need. So you find the area of this, and then you just multiply it by 9 inches. So to find the area, it tells us to use 2 methods: numerical integration and definite integration. So for numerical integration, you could do the same thing as she did with the trapezoid. At the end of the, it's not even open stuff. What was it, 16? Wrong one. Hold up. Wrong one. Cancel. Okay. So this one. Hold on. All right. What am I doing?
Yeah.
So this one.
Yeah.
Okay. So what she did here. So you could do what she did here. Use numerical integration. Pretty much use the same exact formula, but on here, using the X and Y. And then, so for this one, I did area N using numerical integration. So that's what the N's for. Set that equal to the sum of the vector you get from this. So this one. So the vector, and then you get this, right? And then the amount of concrete, I honestly don't know what unit she wants the amount of concrete in. So I just found the area, and then they multiplied it by the width. The width is set to 9 inches here. So 16.699 feet cubed. I honestly don't know what.
And you have to do area.n.
You don't have to. I just named it because of numerical integration. So area found using numerical integration.
Okay.
Yeah. And here you see it's area D for definite integration.
Yeah. Okay.
So for definite integration, you need a function, right? So you find the trend line of this data. So you do the exact same thing as, wait, hold on, where's that? Which one do we do definite integration? I just don't.
That's the one we did the trend line with, so the first one.
Oh yeah, because hers is different than mine, that's why. Oh, here, so yeah, so lost. So you give it the coefficients, not the coefficients, you give it the variables, and then you give it the x, the y values, and then the coefficients, and use len fit, which is what I did here, x values, y values, and then the coefficients, and then it gives us the variable, sorry, and it gives us the coefficients, and then they use tx as well for the trend line. This is the function of the trend line. You multiply the coefficients by the variables.
Mhm.
So tx is the function we're going to use for a definite integral. And there is, I don't remember how many rows, there's like 6 rows here. So we're going to do it from x equals 1. So from the first x value, 0, to, hold up, what the heck? X rows.
So however many you have like in the data.
Yeah, so rows data gives us the number of rows, right? So the very last value, the very last row has the
Right.
last value. This is x
Okay.
bracket rows data. So this gives us
When
the
is-
very, I'm sorry?
When is it again that you use like bracket versus dot?
So for dot, it's just, you're just naming, this is just for like text, you're just naming a variable.
So like area dot d you use.
Yeah. That's a dot. Now, if you're trying to like retrieve a value from a vector or a matrix, you use a bracket.
Oh, okay.
So x here is this vector here, the first column.
Mhm.
So x bracket 1 gives us this value here, 0. All right, and that's where we start. That's our starting x, let's say. And this x rows data. So as I was explaining, rows data gives us the number of rows. There's 6 rows, I think. So this is a bracket, x bracket. So it's going to give us x bracket 6. So whatever the very last value is, which would be at columns, row 6, sorry. X row 6 would be, I think it's 6.88.
Mhm.
So this right here is equal to 6.88.
Right.
You could just write it, but I think she said in one of the lessons, she was like, oh, try to make it more automatic just for practice or something.
Mhm.
So that's what I did here. You use the
And then
function
X,
t
and
of
then
x.
X bracket 1, right? At
Yes.
the bottom. Mhm.
And then use the function t of x and dx, because this is our independent variable here. And then you multiply it by the units, I guess, if you want. And you get this. So they're about the same. So I think I did them right. And then this is how much concrete would need using this method.
Okay.
So like I said, they're about the same. So I think I did it right. But,
Mhm.
you know, probably made a mistake somewhere. And that's just part A and part B. And that says compare your results. I don't know what she wants us to do, like just write it out. Like they're about the same or I think just showing it is enough. I don't know.
Okay.
Now this one was annoying. There's just 2 questions here. And this is the one that's gonna take you the most time. By a lot.
Oh my gosh.
So it says, so this is intensity, duration, frequency. So this duration is return period, and these values here are the intensity. So for part A, it says plot the data for 2-year return period in MathCAD. So what I did was just go ahead and just get all these values on here. So for these would be our x's. D1 would be our duration, sorry, yeah. So duration is our x here.
So the first column is duration.
Duration, yeah.
Okay.
This is for 2-year return period, 10-year return period, 50-year return period, 100-year return period. So that's what I did here. So column 2 is our intensity values for our 2-year return period. And that's equal to the second column of this data.
Right.
And then for the intensity of for 10-year return period, third column, 50-year return period, fourth column, and then 100, fifth column.
Right.
So it says plot the data for a 2-year return period in MathCAD. The duration in minutes is plotted in the horizontal axis. Duration, intensity. So what you do is use ln fit. She asked us to use ln fit instead of lin fit. Use ln fit, which is the gives us the equation or function in this format. So these are it's going to give you a and b. The coefficients a times ln of x plus b. So you have to do less than what you have to do with lin fit. You just need to give it the x and the y values. So for the 2-year return period, the x values are d, and then the y values is I.2.
Wait, sorry. So what's the difference between the lin fit and the ln fit?
So lin fit, it asks us for the coefficients. Remember coefficients?
The coefficients and the x and y values, right?
Sorry, I'm so lost. So it asks us for the variables.
Yes, I'm sorry. Yeah,
So
the variables. I keep
X,
saying that too.
x cubed, x squared, x1, right? Asks
Yeah.
us for the variables. And then it also asks us for the x and y values
Right.
of the data. Yeah.
Okay.
So this one just asks us for the x and y values.
Okay.
So you don't have to do like an f of x with all the variables.
The variables. Okay.
So here you just did C2. What was it? What was C for? C for coefficients, right? C for coefficients,
Okay.
dot 2
For
for 2-year return period, right?
Yep.
ln fit, x values, y values, and then you get these coefficients here. And then instead of multiplying like the coefficients by the variables, since you don't have the variables here, you just use this same format here, a times ln of x plus b. A would be this very first one. So how I did that was, this is C.2 bracket 1. So the first value of vector C.2.
Okay. Well, that's confusing. Okay, so
Yeah.
holy crap. So you did C.2, which gives you just what you're looking for, and then the placement of what
The very first.
C.2.1, the very
Yeah,
first
bracket
one.
1.
Okay. Bracket 1.
I mean, I guess the only way you could do it is like
Just
name
plugging
different
it in.
letters, like different letters for every single one, because you have to do all this for every single one of it. 10-year, 50-year, and 100-year. Yeah.
Okay.
So
Yeah.
I mean, just it makes more sense to me to use the 2 for 2-year.
Of course.
So C.2 bracket 1 times ln of x plus C.2 bracket 2. This one. This would be your A and your B.
Got it.
And then that is your trend line. So for your trend line for 2-year return period is this. So you would plot that. First, you would plot the data, D for your x value duration versus I.2, which would be your 2-year return period. And then you just plot X and you plot your trend line here, T.2x. So that's your trend line, and those are your data points. So then asked us to determine the trend line equation and the R-squared value. So for your R-squared value, obviously you need the actual Y values and your predicted Y values, and then it compares them for a correlation. It gives us R, right?
Right.
So for
That's the same thing we did for the.
yeah, so I dot
Okay.
2 P. There's no dot between the 2 and P, just I dot 2 P is equal to vectorize this thingy right here of the trend line using these D values. So at these D values, it's going to give us what the trend line predicts.
Okay.
And then you just use the core function here, I dot 2 comma I dot 2 P. These are the actual values. These are the predicted values. And then it gives us, once you square the R, sorry, you get the R squared.
Okay.
And then here it just says to find the rainfall intensity for a specific storm duration. For example, 20 minutes. So I just use 20 minutes. So T 20, and then this is your value.
Okay.
Wait, hold up.
That's
Wrong.
a lot.
That is wrong. T dot 2. You see, this is why you go back to your work. T dot 2. Because at one point I was changing around like the naming of these variables because as I was going down, I realized that they needed to be all named differently.
Yeah.
And then I just forgot to change this one thing. So T dot 2 evaluated at 20 is 4.977.
Okay.
So like you already know, you repeat it for every single one of them. So I changed the names as I go. C dot 10, I dot 10, C dot 10 bracket 1, C dot 10 bracket 2, T dot 10 here, I dot 10 P. So instead of 2, you change it to 10. You could just like copy this, paste it here, and then just change all the 2s to 10s. And it should work. Because that's what I did. So it's really not that bad. So you just copy this, paste it here, and then where you see C10, you change it to 50. You change this to 50, 50, 50, 50, 50, 50, 50 right here, and then 50 right here. And it should work. Oh, and then change this to 50. T dot, instead of I dot 10 or I dot 2, you change it to I dot 50, T dot 50, and this stick can stay the same. And just do that 3 more times after the second one, after the 2-year one.
Okay. Yeah, it's the same thing, right?
Yeah, you just change all the 2s to 10s or 50s or 100s.
Right.
Including this one right here to plot it.
Mm-hmm.
And this one I have to change this one.
Yeah.
What the heck? Yeah. So now I honestly don't know what this last one says, but I just guessed. So it says create an engineering worksheet to determine the rainfall intensity for this area in Tennessee, given a specific storm duration in the range 5 to 120 and a return period among those in the table. So I assumed it'd be like, if I input this data, I wanted to output what the answer is, right? I don't know. So like if I were to
say
change
that again, if you were to what?
Like if I were to just like, give me some random years from 2, 10, and 50. Doesn't matter how many. Just like how many would you?
Like give you numbers from 2 to 100.
Like tell me how many years. I mean how many?
Like 5.
So between 5 and 120, give me the amount of numbers you're gonna give me and the numbers.
Okay. I don't know, 3. Yeah.
So okay, 3. Just give me numbers between 5 and 120.
6, 12. 50.
All right, and then need the same amount of years, so 3, right? So in between,
Between 2 and 100 again.
no,
I mean,
no,
two
it
and
has to be 2, 10, 50, or 100, and whatever combination.
Oh, okay, 2, 50, and 100.
So now it should give me answers. You see how it changes? Using this, whatever this is, probably a simpler way to do it, but
What is
it gives
that?
us answers. So it's a little program, right? It's really annoying.
Did you type that or you copied that?
Yeah, I typed it.
Oh, oh my God.
So it might not be the way that it's asking us, because what is an engineering worksheet? Like, what is that? So I assume this, like, let's say I were to just type in whatever values, I want to be able to get the answer. Doesn't matter how many I type, doesn't matter if I type 1 or 100, I should want the values, right?
Yeah.
So that's what I thought, right? And these numbers have to be vectors, so you could do a 1 by 1 vector and then just put a number. But if you were to just put a number, it wouldn't work.
Okay.
Because here it depends on the rows. So intensity, right, is equal to this for loop. I 1, 2, however many rows are on here, right? So it could be 10 rows, it could be 100 rows. It's going to do it however many times it needs to. Right?
Yeah.
So here it's just 3 rows. So it's going to go from 1 to 3. And it's going to count by ones because that's the default for a range vector. So it's going to count 1, 2, 3. And then here it's a conditional. So if.
So you have to put rows duration.
You could do rows period, honestly. Because there should be the same number of rows anyways.
Okay.
Now this is for if statements. So I want I dot I. So what we did here, hold on. You see it, a dot I to assign values to a vector.
Where? Oh, yeah.
So a dot I, where you assign the values to a vector. And I think she did it as well. So she did a, not a dot I, sorry, a bracket I to assign the values to a vector.
Yeah.
So as it goes, it just assigns a vector here. So here we're doing the same, except it's 4 different ones inside an if block. So I dot I, in the case if it's a period, 2. Hold on. I gotta really think this through because I was breaking my brain trying to think of this.
That shit looks confusing.
Honestly. All right. So what it's gonna do once it does, it's gonna determine how many times it needs to do it, right? And then it's gonna do this. It's gonna move on to this.
Okay.
So now it's gonna look at the first one because I is equal to 1, right? It's gonna look at the first value of period, correct?
Right.
And in this case, it's 2. So if period bracket 1 is equal to 2, it's going to use this formula right here.
Okay.
All right. And in this case, let's say it gets to 3. So I equals 3. If period bracket 3 is equal to 100, so it would get all the way down here. It would say period is not equal to 2, period is not equal to 10, period is not equal to 50. All right, period bracket 3 is equal to 100, right? It's going to use this one.
Right.
All right, so got that out of the way. Now these are the trend lines for each of the years. 2, 10, 50, and 100. So that's why I named them all differently. You see, C100, C100. So it's this, but here. And in this case,
2, 10, 50, 100. Yeah.
Yeah. So the X value, now it has chosen which equation it wants to use, right? So let's say it's chosen this one. It's going to do that
That function.
Yeah, so if I equals 1, it's going to say, oh, period bracket 1 is equal to 2. So I'm going to use this equation. I is still equal to 1, right? So it's going to do intensity bracket I is equal to C dot 2 bracket 1 times ln duration bracket 1.
Oh
so it's
no,
going to look at
that's
this value.
that's way too much work.
Honestly, it's probably more complicated than it has to be. But it was kind of fun after I actually finished it. Because you could input as many values as you want here. Obviously, they both have to be the same amount of value, and it would give you an answer.
Okay.
So just for fun. I don't know. 7. Wait, hold up. I gotta delete it first. So 40, 45, 67, 86, 85, sorry. 35. I don't know how many values are left. Okay. So
You have to do the same amount.
7, yeah. So let's just do 2 for all of them. I don't know. And it's gonna give you 7 values. It's
But
honestly.
how did you come up with that?
I was just dying.
Oh my god. Yeah,
Like I said, it's
not.
probably more complicated than it has to
I
be.
would not know. I don't know. I don't know what I would do for that
And
one.
then it tells us after you've done your worksheet, I don't know what the heck that's supposed to mean. Your engineering worksheet, it says test your worksheet using the following data. And that's what the values that I had on here were.
That's horrible. Why would she make us do that?
You see, so 10, 20. So it calculates them all in one go instead of having to repeat them all. Like, you could do any combination you want and it would give you a value.
But that's us like trying to come up with like I guess
like a program to use.
like a program, yeah.
Yeah.
That sucks.
Like I said, it works. It's probably like the other thing. It's probably more complicated than it has to be, but it works.
Well,
and that's all that matters.
If it works, that's all that matters, exactly.
And then from here, I think I'm done.
Okay. So the last one is pretty bad.
Yeah,
but that's about it. The other ones are like just repeat, you know.
Until here, it's pretty good, and then it dies.
Okay, Rudy. I guess I'm just gonna go over. You recorded this, right?
Yeah, it's probably gonna take a while for it to get out of like 380p, but because I don't know, it takes like 2 hours to even be like viewable. I don't know why YouTube takes a little while to like process the video.
Okay, I'm gonna finish up the practice exam because I still have to finish the equations, and then I have to start the homework too.
All right. So
I think I'm good. Thank you so much for all your help. Like, honestly.
No problem.
I don't know if anybody else is on, but I think it's
no, they're not.
All right. Thank you.
All right, you're welcome.
Talk to you later. Bye.
Yep.